Welcome, 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 everyone, to the Nest Egg Builder Show. It's Tuesday, and we have a really special guest. I want to remind you of we work with people who are building their portfolios with passively in commercial real estate across the United States. If you'd like to have a conversation with me, just set up an appointment. And I am in this LA area. I'm in a small town called Sierra Madre. We did have to evacuate during the fires. And the reason that I invited Al Cobb on was because he has a way of building that I think is very, very important to rebuild LA. And in his honor, I found, and he's treating us to this, which I thought was very special of him. And I found this little quote that I thought kind of applied to treat everyone special. We are here on earth to do good to others. What the others are here for, I don't know. W.H. Auden. So Al Cobb is from West Virginia. That's where he lives with his lovely wife, Annie. They are, it's called SIP. It's structural insulated panels that I don't know exactly how they're built. I just know the effect of them and the results of being fireproof and earthquake proof, which are two of the things that we really care about, besides mold proof and termite proof, and a few other great results you get from using this. It's not stick built. So for LA to rebuild itself, it really needs to be looking at doing it differently. I was driving by a couple homes the other day that are being stick built in Arcadia. They are multi-million dollar homes, and I don't quite understand why they wouldn't be using the SIP panels, which would also build beautiful homes and take a lot less, probably money because of the way it's built. So today we have Al Cobb from West Virginia, and he is not only is he a contractor and builder, he also is a teacher. He travels around the world and speaks. He has been in the business for well over 30 years. He's almost caught up with me in the business, just in a different part of the same business, real estate. And I am really anxious to hear what he has to say, and I hope that you will bring your questions with you because a lot of people don't know what SIP is, and SIP's been around for quite some time, as I recall. So, Al, please take it away.
Very good. Thank you, Peggy. Peggy, I really appreciate you giving me the opportunity to come and speak to the group. I'm going to provide with some basic generic information. I've got a small PowerPoint presentation that I'm going to now open up and see if we can't take this to a full screen. And let's see if this gets us to where we want to be. As Peggy said, I've been in the SIP industry for a good long time, both as a manufacturer, as a builder, designer. I work in engineering. I train everything from inspectors to architects and engineers that want to work with SIPs, as well as I travel around the world, and I also assist in setting up SIP manufacturing facilities, one not too far south from where a lot of you are sitting in Southern California. And you are correct, Peggy, that SIPs have been around for a long time. In fact, they go all the way back to the 40s when the
Mm.
process of lamination was first being reviewed by the Forest Products Lab in an effort to better utilize the natural resources that are what we see in the forests all around the U.S. So what I hope to give you here today is going to be an outline of really what is a SIP, because I'm willing to bet that a lot of you may have heard of the term SIP, but didn't really know what it was unless you were drinking some wine with friends perhaps. But a SIP is a structural insulated panel. It is in essentially three components. It's going to be rigid skins on the outside. It's going to be a foam core, always a closed cell foam core that makes it a high insulating value, as well as a structural adhesive that brings everything together and makes it a cohesive composite building material. Now on the facings, we typically would use OSB. Throughout North America, it is the most common skin, but we can also utilize a metal skin or concrete. MgO stands for magnesium oxide, which is actually a replacement for drywall and has some great characteristics in terms of not being affected by water, moisture, and has had good fire resistance. And then we also can utilize composites of different types, which give us a very unique panel that is very light, has some great strength characteristics, and gets a little bit outside of the scope of the work. So let me move on to the rigid insulation core. Now the core of the panel, as I said, is going to be a closed cell foam. Typically it's expanded polystyrene. Some of you may have seen foam and mistakenly referred to it as styrofoam, which of course is an extruded polystyrene, but very close and similar chemical characteristics, physical characteristics as well. They all provide a foam core that prevents air from moving through, acts as its own vapor retarder, and provides the structural integrity when structurally laminated to that skin on either side. The structural adhesives are really no different than those that are used within the building trades when you're familiar with working with glue lams or I-joists, LVLs, things of that nature, which would be referred to as an engineered wood product, would use the same types of structural adhesives. So we're not using anything that isn't already being used in the building trades. Now these panels can come in sizes all the way up to 8 feet by 24 feet, is typically what's referred to as a jumbo panel. Of course, plenty of manufacturers around the country and around the world manufacture nothing more than a 4x8 panel, but OSB has kind of taken the lead in the SIP industry, certainly in the US, because it has the capacity to be manufactured up to a 4x8 panel. Now, once we have that 8 by 24, once we have that panel manufactured, we can use it for walls, roofs, floors. We typically do not use them for interior partitions because we need that open cavity of interior partitions for mechanical trades. The reason we might look at using a SIP on a wall is because one, it's fast when that panel is provided in a way that everything has been one, pre-designed, and two, pre-manufactured, meaning that your doors, your window cutouts, your rake angles, roof overhangs, pitches, everything is all pre-cut in the factory. So it's a very quick way to assemble a panel, a home or commercial structure. It doesn't matter. We work both in residential and commercial routinely. It gives us good control over the materials. Certainly, the material is less likely to find its way lost off the job site. The panels come pre-labeled. They're ready to stand up. It solves a lot of the problems because we are figuring out all of the necessary issues while the CAD operator is sitting at the CAD environment designing the building. Typically, we take standard drawings that in many cases are designed for stick frame and convert that over into a panel layout drawing, which I'll show you shortly. So here we are using panels in a wall scenario. We can provide straighter and truer walls, also very tight construction. One of the big advantages of the SIP is the fact that it's very energy efficient. And one of the reasons we get high levels of energy efficiency is because we also have high levels of air tightness. We can certainly use panels on the roofs, and this is where they do have a lot of advantages because now you're dealing with a structural component that also provides all of the insulation at the same point in time. If you have cathedral or vaulted ceilings, if you have large spans, a panel that is upwards of 12.5 inches thick has the ability to span a great distance. Now, what is a great distance? Some people would say, well, 12 feet is a great distance. Some would say 24 feet is a great distance. It's a function of how thick the panel is, how far there's the panel being asked to span, and of course what the roof loading is on top of that panel, which determines how we design then the panel system and how it lays over top of either structural members, interior load-bearing partitions. It might be over timber frame, which is very common, purlin beams. Anything can be utilized to help support and work in conjunction with those panels to span the distances that are needed based on the design of the building.
Hmm.
Moving on, so that's a general overview of what a SIP is, where they can be used. I want to touch briefly on the National Association, which is an overview of all of the major SIP manufacturers within the US. Now, it's a national trade association. I actually sat as the president of this association for 3 years, so I know it quite well, and most of the members throughout North America. And the one thing that's important to understand about members that are a part of this trade association that are manufacturers is they have minimum quality standards that they must maintain. And this includes their panels have been tested, that they have a code report, and that they submit to third-party inspections. So now the client or the customer can feel confident that the panels that are being delivered to their sites have met the quality control standards and are fully code compliant. And that code compliance extends into things like seismic testing. So I've been involved in seismic testing that allows panels to be used all the way up into D, E, and F category seismic zones. And of course, they've been used throughout California where seismic issues are certainly a concern. And this is just some of the testing that panels will go through to meet the requirements and have code compliance, which includes the California Building Code as well as LA Building Code. So there are 3 members within SIPA, the Structural Insulated Panel Association, and I've included their website for your use later. SIPS.org is the website for that association, where they have a slew of information, including a lot of training videos, and those training videos were videos that I actually developed and put up online for SIPA, so you can see my smiling face again through some of those training videos, but it's a good place for additional information. Going back to the 3 manufacturers that some of you may be interested in, that all service California and have the applicable code compliance. There's one in Washington State, the name is Premier, one in Tijuana, which is Preflex, and the other is up in British Columbia, actually in Delta, BC, which is called Insulspan. Now, Premier is by far the largest. Insulspan's been around probably a little longer, but is a little bit smaller. Preflex is a new kid on the block, so you're dealing with a company that's significantly smaller and still getting their sea legs underneath them, but a good company nonetheless. All 3 of them have the ability to provide panels that are fully code compliant and ready to service work in California and including LA. So the question that I get asked, of course, a lot is, well, what are the advantages of SIPs and why should I even be considering looking at SIPs? And of course, the answer to that question in some cases depends on who it is that I'm speaking to. If I'm speaking to a builder, the top 2 on my list are usually going to be the 2 biggest concerns. How quickly can I get the building up? And is it going to take specialized labor or more labor? And for the builder, I'm happy to say, well, if your panel package comes pre-cut and has been pre-designed, then you have a package that should go up very quickly. And because a lot of the work has been done in the factory, the need for specialized labor can in fact actually be reduced. We can put up structures with fewer people and put up the same size building when we are working with a structural insulated panel package that has been designed and prefabricated correctly. Now, the third on my list is energy efficiency. I wouldn't, and I'm a builder, so I can say this, I wouldn't say that a lot of builders consider energy efficiency the top of their concern, but I can tell you it's probably the concern of perhaps the person paying the utility bill. I can tell you that when it comes to incorporating energy efficiency into a building that you own, especially one that you may actually rent out, it's often a trick that will be used for people looking for income generating properties, is to build rental properties and incorporate the utilities into the rent such that they know what the utility bills are going to cost them, because it's not uncommon for a SIP structure to see energy bills being half of that which is for conventionally code minimum stick frame structures. So if the owner knows that the utility bills are going to be half what they would suspect they're going to be by rolling the utility bill into the rent. It's a common use for people that are building with SIPs and renting those properties out. Next on my list is indoor air quality. When you build a structure that is very, very tight, you get two things. You get high levels of energy efficiency because we don't have unwanted air movement through that exterior envelope. And two, we have the ability to control that air in terms of filtration, fresh air inlet, exchange of air, things that are part of the HVAC system that maintain a good high level of air quality. Sound is an issue, depending upon where you live. A structural insulated panel house that not only is airtight, but has that composite panel, does a wonderful job at blocking out the vast majority of sounds that are often going to find their way through an exterior envelope. Fire resistance, panels have certainly been tested in all manners, of course, in terms of fire resistance, and they all have the ability to meet the requirements, whether that be as a fire rated assembly, whether that needs to be a 30, a 1 hour, all the way up to a 2 hour fire rated assembly. It's a function of how that panel is covered, what it's covered with, and the detailing that goes into that that design that allows the panel system to meet the fire rating requirement that is needed for that structure. When we get into manufacturing, the structural insulated panel manufacturers of today often use CNC cutting equipment. This means that the CAD designer, while sitting at their CAD station, can work on the design, and that design might look like this, and that design then lays out all of the windows, the doors, the dimensions, the spans, everything that is needed that allows the architect's design to be translated into a panelized system, both in walls and roof. This is a very simple structure, but it's big enough that it allows you to see some of the details that I'm referring to. And now with all of that design, it can then be transferred literally digitally right into a machine like this, and whatever we draw, that's what it cuts. That's why when a panel package shows up to a job site, the tolerance of dimensions and accuracy can be held to a very high standard because of the fact that we're using CNC technology and we're designing in a 3D isometric environment that allows the computers to fit everything together, not somebody working in the mud and in the field trying to figure out what the angle is they're supposed to cut on that next 2x12 so that it fits into the compound valley that is the roof angle, and they are not really sure what it's going to be. We let the computer do the work and the CNC saws do the work that they do so well. Now, once those panels are up, we take an extraordinary amount of effort towards making sure that they're airtight by using a number of different types of sealing methodologies. This is just one. It can be an expanding foam, could be a two-part foam, could be a caulkable mastic, might be compressive gaskets, it could be tape, and everything that goes into that is designed as part of the system so that it becomes very airtight. Now, how tight do you say? Some of the testing that's been done by some of our national laboratories, including Oak Ridge, show that the difference in air leakage or air infiltration when comparing a stick frame structure versus a SIP structure, there's quite a large distance in terms of how much air leaks through there. Now, I will admit that if I'm living in an environment such as where my daughter lives in Glendale, just north of LA, they don't worry a whole lot about the energy efficiency concerns because the weather's so darn nice out there. And I'm jealous about that as I look out the window and see that it's 11 degrees outside. But nonetheless, controlling that air movement means that we can also control good air quality. And it never hurts when the temperatures do rise or fall. We certainly give a more energy efficient structure by keeping that envelope nice and tight. One of the other things that I wanted to point out, because this often comes into play with a group of such as yours, is taking existing structures and retrofitting them into a new or more energy efficient structure. The SIP industry has expanded its product line to include something that might be referred to as a RIF, retrofit insulated panel. It's also referred to as a nail-based panel. Now I want you to think of the design of the SIP as I showed in the beginning of the presentation, and now just think of getting rid of one skin. If we had a SIP that only had a single skin and then foam laminated to it, it allows us to take that panel, and if we are retrofitting a structure and putting new roofing or new siding on it, it is the perfect opportunity to take a nail-based panel or a RIF and apply it to the outside of the structure to give that structure new life in terms of energy efficiency. It's like wrapping a nice warm coat around an old building and bringing it up to modern energy code requirements, and doing it with a SIP-like component, but one that doesn't have the structural or the code testing because it doesn't need it, which makes it much less expensive. And now we're simply applying it to an existing structure. I thought I'd throw that in there because I figured some of the group might find that interesting. Once we have a structure nice and tight, we do things like blower door tests. And blower door tests allow us to verify that the structure is in fact airtight. And this is also done for durability insurance, in that if I know I don't have leaks in that house, I know I don't have unwanted air movement and moisture creating mold issues. And so these blower door tests simply depressurize the building and allow the builder to, one, determine what the air change rate is, which is part of the model energy code now. In a lot of places in municipalities, all structures have to go through a blower door test. But also, where we do find leaks, it allows the builder or the SIP installer or whomever who's going in to verify this, where those leaks are. We then have other methodologies to go back in and incorporate tapes and mastics and injected foams to make sure that we bring that structure up to as tight as we possibly can. This is probably the question that I get asked more than anything, which is, of course, well, how does SIPs compare in cost to stick framing, or how much does it cost? I like to put it in terms of this. If all I'm doing is comparing a SIP to a stick frame structure, I'm going to say, well, I don't know, it could be more, could be less, could be the same. I need more information. And the reason I need more information is because I don't know what standard we're comparing. If all we're doing is building a house to a code minimum standard, then I can assure you the SIPs are going to cost more, because the SIPs perform more. As soon as we start raising the requirements of the building or the structure to a performance level or a energy performance standard, then I can say, well, now that stick frame structure is going to start to cost more money. Are we less than the model energy code, or are we more than the model energy code? Are we still dealing with Energy Star or some of the other performance metrics that are out there, such as Energy Star Plus? Or once we get into things like zero energy buildings or passive house or living building challenges, all of these are standards by which buildings are being asked to perform at a much higher level. And if you are going to do that in a stick frame environment, I can assure you that that cost is going to rise significantly. However, if you're building it with SIPs, the SIP cost is still where it was from the beginning, from the get-go. I didn't need to do anything additional to bring that SIP up to a higher level of performance. It's already there. So I build structures and have been involved in structures all over the country that were off-grid, were net zero energy, and did so with a SIP envelope and very comfortably complied with the energy performance requirements in order to get the building to perform to that level. So I'm not going to stand here and tell you, oh, SIPs are going to be less expensive than stick framing, but I will go out on the limb and tell you they could very well be less expensive if you are trying to build a building to a high level of performance. If you want to be a code minimum builder and developer and build thousands of homes per year at code minimum, then I can assure you, you're probably not going to be looking at SIPs as your go-to component. It's just not typically what we see in the environment. So that's an overview of what a SIP is. You have a general idea of how they're manufactured, how and where they're used, and then this is the end of the slide presentation portion, of course. This is my information. It's certainly how you can get in touch with me, and I'm certainly happy to answer any questions as we move forward. Again, I'm very delighted that Peggy asked me to join you here today. I hope that from a time constraint, I'm where I need to be at this point in time. And I know that Peggy was going to open this up for questions, and I'm happy to answer anything that you have out there. How does that sound,
I,
Peggy?
I got a lot of them, but does anybody else have any questions before I monopolize the rest of the
Oh,
time?
I always have questions, Peggy.
Yes, Marianne, anybody who has questions, put your hand up in the chat, not the chat, but you know, where you raise your hand. Yes, Marianne.
Yeah, I've been interested in SIPs for a while, so I have looked at some. Working both in California, Chicago, and Florida, I can see the use of SIPs for various things. Obviously, California, it's the earthquakes, but it's also, after all the things that just happened around LA, is the fireproofing. Um, what would what would your suggestion be in terms of the type of SIP? Would that be a cement one? What is your most fire resistant coating to start?
Well, it's an excellent question, Mary. The fire resistance of a SIP will, in almost all cases, rely on the combined cladding that is applied to the panel in order to get the maximum level of performance. You could say, well, a metal skin SIP might be ideal because metal doesn't burn, but if it's a structural panel and it has a metal skin, that metal gets hot enough, it loses its structural integrity, and now all of a sudden you've got a wall that doesn't want to stand up anymore. I mean, this is true for, we've seen it before, buildings that are made out of structural steel and they fall down when they get hot enough. So the best fire resistance methods, in my experience, have been what is the cladding that's being used, how is it being applied, and then therefore, once that is taken care of, the testing of that whole assembly can get us up to those 2-hour fire ratings, regardless of whether it's an OSB or a cement skin. Um, yeah, I wouldn't say one is tremendously better than the other. As much as you might think, well, cement's got to be better, but it's got a lot of disadvantages as well. The panel that you will find without question the most testing and code compliance are going to be the panels that are manufactured with an OSB skin. Okay.
Oh, that's
Uh,
interesting.
yeah. Now, if you
And
were
would
down,
that also work if you were retrofitting? For instance, I also have a house in the mountains that has been under evacuation twice. It's
right?
survived, but I feel like our chances are getting worse and worse. Um,
I
so,
understand. I understand.
and I'm certain if we were able to find something like that, like to clad houses already existing, we would have a big market for it.
Right. Right, I agree. Again, from my experience, I certainly can't stand here and tell you if you want a fire resistant house, just build it with SIPs and it's fire resistant. Obviously, that's not the case. It requires a layered approach of how to take what is a good building product and then layers upon that, which then give it the fire resistance that is needed for the environment that it's being built in.
Okay.
That would be my experience that I'm dealing with.
Thank you,
And
Marianne.
okay, yeah, I don't want to be the only one asking. You can come back
No,
to.
it's a lineup. Uh,
Okay.
Eugene
Okay,
and then Ted.
I'm trying to prevent the engineer in me from asking too many questions. Um, so I'm really interested in because I don't invest in the left coast. And I hate what's going on out there, but that's not where I invest. So what kind of penetration do SIPs have in the Midwest, Southeast, and Southwest?
What's
Um,
hurricanes? Tornado.
in nationally, Eugene, we still are less than 2%. We fluctuate between 1% and 2% in terms of total um, uh, 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 family structures, single family structures. Right now, I would say SIPs are seeing a big surge in areas that is multifamily. And I would say also a lot of SIPs are being used in Well, they've always been big in churches and um, a lot of schools are coming online using SIPs. Um, the largest market for previous decades before the 2000s was definitely the Northeast. The Midwest is a good market. Southern Midwest is Texas area is a phenomenal market, and the Southeast, I would say, is probably the next hotspot for SIPs for a whole bunch of reasons, including their ability to resist the hurricane and natural disasters that we see in the Southeast that are hitting us the most in that area. I've built a number of structures that were good all the way up to 200-mile-an-hour winds in the Keys, where it doesn't get much more difficult than that. And SIPs, I would say, don't have much problem handling that kind of force. So we see a lot of it in the area in Florida and up and down the coast where the high winds are an issue. They do have great seismic capacities, so they do get a bump in those areas. Um, uh, they're being used in all areas. In most cases, you don't even know it because as quickly as the building goes up and then starts getting covered by siding, you drive by the next week and the building's there and you didn't know it went up with SIPs. So I'm not
So
sure if
that
I
leads me
answered the
to,
question.
yeah, you did. That leads me to my second question, and then I'll let other people. If I build with a SIP, will my insurance go down?
Ooh, that's a great question. We've heard it a number of times. And the one area where I would say you could capitalize that is on the um, fortified. I'm trying to remember the name of the plan. It's fortified home something. It's a program that's overseen by, it might be the DOE. I can't remember. You caught me off guard. Um,
I'll send you an email with
Send me
that
an
question, and
email
we
and
can,
I will get
yeah.
that back to you. You may find the information on the SIPA website. I think it might be on there, but I know it's called Fortified Home. It is a program that addresses structures that are built to a higher level or a higher standard, and it is specifically for the insurance industry so that it can recognize when I build a better house, it shouldn't cost me as much to insure it. And
Okay.
it's an important point and a great question.
It was
All right. Thank you.
it was on the SIPS .org site. I did notice that.
Okay.
Ted, thank you, Eugene. Ted.
I've got three questions at the moment. Uh, Generally speaking, what size buildings are you aiming this technology for?
Ted, I've done micro homes or ADUs that were obviously 200 or 300 square feet, and I built the world's largest SIP structure in North Carolina that was a K through 12th grade school that was about 500,000 square feet. I don't know that I would say we're targeting a particular size. I would say that um, when projects have complexity that can be solved by CAD design work, the SIPs sometimes get a good bump in being usable. I would also say that depending upon the structure's internal support system, you can get a good use out of SIPs. I've done, say, gymnasiums and churches where glue lams and beams and trusses and supports were at, an 8, 10, or 12-foot spacing. If you were asking me to do a flat roof on a building that had to span, 50 feet from wall to wall, and I can't do that with a SIP. I have to do it with some additional structural components, whatever that looks like, a truss, a beam, a purlin, a timber, or interior supports. So whether a building is a good candidate to be used for, or SIPs to be used on it, is a lot of it is a function of the initial design of the structure. And I've seen buildings that were, homes that were 3,000 square feet that I said, no, don't use SIPs on that roof. You'll pull your hair out and you won't save any money. Or I've, seen 50,000 square foot buildings that were churches or schools or libraries, and the list goes on, that I said, this is a slam dunk. We can do this out of SIPs with no problem whatsoever. So size is more of a, it's more of a function of complexity and support structure that helps answer that question, not the size per se.
Thank you. Before you ask your next question, would you stop the share, please, Al, so people can
Oh,
see
certainly, I can do that.
better? But God, I have two screens, so. Okay, Ted, next question.
I appreciate his having left the contact information up long enough to get a copy. Thank you. Is there any evidence at the moment as to what kind of structures survived the California fires?
Not that I'm aware of.
Doesn't matter
Yeah.
what they were built out of, they all burned down?
Nope. My nephew had a metal home, and we don't know whether there were SIPs underneath it, but his home was saved. He's the only one on the block that was saved. Everyone else burned down. All the stick built, but
And it was probably what, a metal cladding then, Peggy?
I can't answer that. I never even thought about what the structure was until he looked at it and knocked on it after the fires and said, well, I won't tell you how he said it, but he was really happy that it was made out of, had metal exterior,
Yeah.
concrete inside, as I
Yeah.
recall.
And I'm not an expert in certainly California, certainly fires. I've been involved in a number of projects where fire was high on the list of concerns. And in most of those cases, it becomes uh, concrete and metal used in cladding materials, and tile roofs and things of that nature that we have, or metal roofs that have a better resistance. And then the other thing is we close up all the vents and we get rid of ways for the sparks to find their way into a ventilated space. Because when the wind blows and the sparks fly, they get sucked up inside of the buildings in the vents, and that there's now very clear products that are specifically designed to prevent those their spark arrest ventilation filters that are used in soffits and fascia vents and things of that nature.
Hmm. Great.
What's your third question, Ted?
Third question is, given all the advantages you presented, it would seem almost a slam dunk. Why isn't everybody going this direction? Obviously, there's got to be some objections. What are they?
We get asked that an awful lot, and I would say that there's a number of reasons. When people can't find builders or installers who are familiar with SIPs, they often get cold feet and go back to what the builder wants them to use. And the builder wants you to use what he's comfortable with, because the builder has not bothered to either educate themselves or better understand how a SIP might be a better product for their clientele. I can tell you, anybody that's building at a code minimum level and is concerned about just build, and the paper contractors of the world are not interested in using SIPs, because they know they can build a cheaper structure by staying at the code minimum level, and they don't have to worry about re-educating or training their plumber, their electrician, their roofers. Everybody knows what they're doing, because we've been building with stick frame houses for 100 years and not much has changed in the technology. So they know it, they understand it. The other thing I would point out is the SIP industry back in the 80s or 90s, I feel they really shot themselves in the foot when they promoted SIPs as being a real do-it-yourself system, suggesting that anybody could buy a panel package and put it together themselves. And unfortunately, a number of those projects ended up becoming problems, because the simple matter of knowing how to seal and properly make a building airtight wasn't followed properly. And then they ran into a number of black eyes within the industry. And our industry has dealt with a number of those. Some of them became high profile, like once up in Juneau, Alaska, they had an issue where a number of houses had to get rebuilt because they were in a horrific environment from the standpoint of wood construction. And it was very clearly improper job done by installers. And I get called to the witness stand, and I do a lot of forensic investigation on SIPs all over the country. And I can tell you where SIP projects do have issues in a lot of cases is because the the builder didn't understand how to incorporate the detailing of siding and roofing and properly seal the panels, and their installers were not trained and didn't know what they were doing. And SIPA and myself and the SIP school and others have provided a myriad of training opportunities to make sure that panels are used correctly. And I'd like to think that those are the big reasons why we're still only at 2% market share.
So so can I summarize what you just said by saying it isn't the tool, it's the user?
Oh, 100%. Yeah, I could have said it and we'd be already on to the next question. I mean, and so many times I hear, people will say, oh yeah, I know the Smiths built their house a year ago out of those SIPs and it took forever, so I'm never going to touch SIPs. And the reality was it was the builder who never bothered to get trained, thought he knew how to build everything and ended up building himself into a corner. And then what gets blamed? The builder or the SIPs? And it's the same old story.
That's why my slogan is you always pay for good accounting one way or another.
It's
Yeah.
true.
So I have a couple questions and then we'll go back to Mary Ann.
Thank you, Peggy.
So it looks like you just do the exterior, not the interior. And what about, and in that doggy doors? So there's a lot of animal people, they have doggy doors. So my question on the doggy doors is there a way that it's safe in case like a fire, like you're off, like a lot of people were at work when these fires happened and they had animals and the animal,
I'm
did the
well.
fire get inside the house?
Hey, I'm not sure I've ever been asked that question. So thank you for that.
Me.
That's great. In my experience, and I've got a dog, but in my experience, the dog doors are mostly through the doors themselves. If
Yes.
one had one that needed to go through the wall or the wall panel, it could easily be done. I've cut holes in panels for a myriad of things. That and modifying a panel is not difficult. And in some cases, this goes back to the engineering because the panels are as strong as they are. We can go in and make changes to a panel, like add a window, add a door. And in many cases, I don't have to worry about studs. I don't have to worry about headers because depending upon the loads that I'm dealing with, I can cut a new window in a panel. And once I've cut 4 sides and relieved the foam and put lumber back in it, I've got a rough opening. I'm ready to go. I didn't need headers and jacks and other engineered components to get that window where it is. The same could be true with cutting in a doggy door or any other type of doorway through the panel. You cut the opening, frame it out, and put the door on it, and you're good to go.
But what about, do you only do exterior? Do the SIPs only do exterior?
Yeah,
Or do they do-
I had mentioned that the SIPs, because they have the insulation values that they do, and because they make it a solid composite panel, the the electrician, the plumber, the HVAC contractor, the cable guy, the list goes on and on. If you think about that, in most cases, they're using the open cavity of the interior partitions to move a lot of their mechanical systems through the structure. Now, where I live and where Eugene lives, we don't put a lot of plumbing in our exterior walls, which is fine in a SIP structure because we don't want, we don't do it because we don't want our pipes to freeze. And so therefore, put it in the interior partition anyway. If the exterior is a solid foam envelope in it that's a SIP, it's going to perform the way we want it to perform. Everything else should stay in the interior uh, interior partitions. Now, there are a few exceptions where SIPs can be used in an interior partition, but it's very, very seldomly done.
So there's that stick built interiors?
It could be stick framed, it could be metal stud framed, it could be yeah, it's going to be conventionally framed.
All right, thank you.
No doubt.
Mary Ann.
Yes. So do you work with individuals on individual projects? If I had a
I
project
do.
I wanted, okay, and
Yep.
if I have a plan that has to be converted, is that something what you do? I have one that supposedly would be good for a SIP,
Mhm.
It's kind of a simple plan. It's kind of a mid-century modern with a high ceiling,
Yep.
one
Yep.
kind of.
Yeah, I do that. I have designers that work for me, and those designers or in my company through Cobb and Associates, we often do design work for manufacturers, for some of the startups who are just getting their feet underneath them in terms of designers and design experience. We provide that experience to make sure that designs are being done right. And I often work with independent homeowners who are saying, I need somebody to help me out. Now, I'm not going to be the guy there doing, I'm not going to manufacture the panels and I'm not going to be there to install the panels, but
Oh,
I
no.
certainly know the people that can make and install those panels almost anywhere in the country and make
Well,
sure that you're making good decisions.
I'm an investor, so I'm interested in doing more than one, but obviously I want to do a trial
Sure.
balloon. I do have some builders and people that I work with that
Mhm.
would be available to learn either on the job or at the SIP training.
Yep.
Is that I just look for the SIP schools and I can find out about the training? Is that?
You can go to the SIP school and look for training. You can also get some free training that is on the SIPA website. It's called the BEST program, Builder Education and SIPS Training. I developed that course and it's free for anybody to go online and take it. So if you had a builder that's like, man, I really want to know what these SIPs are all about, great place to go spend 6 or 7 hours listening to me yammer on. Um,
Yeah, thank you.
but no, I'm more than happy to. And of course, you can go to the SIP school where we do provide classes. We teach classes right here in my restored 1800s bank barn in West Virginia that's completely wrapped in SIPs, and it's really a nice place. So we do classes typically in the spring and the fall.
Do you do them on Zoom?
We don't. I should probably be doing that, but I've only got so much time, and I'm spread pretty thin as it is. But
Well,
I get out there.
maybe we videotape you doing it in the process.
Yeah, I've got
Part
a
of the
lot of those.
film
I just need to
industry.
upload them all to YouTube is what I
All
need to
right.
do.
Windows in and curved walls. But
Okay, windows and curved walls or curved windows as well. Arch top windows. That's one of the beauty of CNC fabrication because what we, excuse me, have the ability to do is take that CNC router head and cut the perfect arch top window for whatever Marvin and Anderson dream up. We can cut the opening so that the RO is perfectly accommodates that window. And as far as arched panels, I have been involved in a number of projects where we specially laminated the panels so that they were arched and we literally had a true bow in the panel. I've done it on a number of projects. In typical construction, it's not done. Most of the time, we will segment those arches so that we have short pieces that go around the curve to give you the end result, which gives you that arch or that curve. So you have options of doing it either way.
that's great. Thank you very much.
Can I ask one more question, pretty please?
Yes, you may, Marianne.
Speaking of windows, is there, and I'm still on the fire thing right now, even though I do interested in the hurricane stuff as well, but I do know about hurricane windows. What I'm wondering is there a specific type of window that is best if we're trying to go for the fireproofing side, or do you put some kind of a metal, you know,
Uh,
shutter
on,
on it or
on
something?
the projects that I have been involved with where fire was on the high end, it always involved a metal shutter that covered the window when required. I'm not an expert on the windows that are sold to the public as a fire resistant type window. I'm just not familiar with it.
Well,
We'll have
metal
to look into
shutters work.
that. That's a great question. Was thinking kind of about that, but you asked the question. That's great.
Yeah.
Well, great minds, Peggy.
Yes. Does anyone else have any questions? I know some of you came in a little later. Doug, are you on, Mr. Dow? You work with a lot of builders. I wondered if you had some questions.
This isn't the real Dell,
Oh, who is it really?
Dylan.
Dylan. Oh, welcome, welcome. We're so happy you're here. It's been a long time. Oh, it's too bad. We would love Doug to be here because he works with all the build to rent people. So do you know about build to rent, Al, and people going in and building a lot of homes in an area and then rent them out?
Yes, and I touched on that earlier, that
Yeah, yeah.
where the energy efficiency of a SIP structure, and a structure designed to be uh, a structure that's designed in a manner that it is SIP friendly, meaning we take the best possible advantage of what a SIP can do, both in terms of energy efficiency, span, strength, installation, ease, everything that could possibly be done to make it as friendly as possible. We get the best bang for our buck with this SIP envelope. And then those structures that are then rented out, and I know this because I know a number of people that are doing it in Florida and the Midwest and other areas, where they know that the average renter is going to perceive that the appropriate utility costs are going to be X amount of dollars. Let's just throw out a number and say $300 for their utility bill to pay for the heating or cooling. Well, as the owner, and having built with SIPs and put in an energy efficient components and pieces that make it substantially less expensive to heat and cool, now all of a sudden, as the owner, you've only going to have an average heating or cooling bill from the electric company of $150 or $100. I've done one project where my total air heating and cooling costs for the entire year was under $200, and it was a 1,200 square foot structure. That was the total cost for just running the mini splits to heat and cool that building that was a full SIP envelope. But as the owner who's doing a rental, then you can incorporate the cost of your rental and throw in the perceived $300 rental cost. And when at the end of the day or the end of the month, you're pocketing an extra $150 because the energy efficiency saved you the cost of that utility. It's a technique I've seen used by a number of folks that embrace truly building something energy efficient.
Eugene.
Okay, so I'm one of those investors. I just look at the bottom line numbers. And I use two architects here in Chicago for all of the work that we do. I have no idea whether they know about SIPs because quite frankly, I never asked them. I just said, here's our target numbers we want to meet. If I tell them about SIPs, should I assume that they know about it, or should I just say, I learned about this SIPs and here's where they should go to find out more information about it? Because assume starts with ASS for a reason, because you can make an ass out of yourself. So should I assume that they know about it or not?
I would be willing to put a bet down that they know about them. Whether they've
Okay.
ever designed or built with them, that's not a bet I would take. SIPs are ubiquitous enough that anybody that's got an AIA behind their name has probably dealt with, heard of, or aware of their use. Doesn't mean that they've
Okay.
designed with them, but they know about them.
Okay, thank you. That's what I wanted to know. Thanks.
Yeah, so how would you ask that question of your architect? Whether they're doing a comparison when they're putting that together, are they looking at SIPs to create whatever the product is that you're going to build, or do they just standardly go to stick and
So my advice there was, if you don't have the architect yet and you're looking for an architect, I recommend that you reach out to architects who sell their services with an emphasis on green or energy efficient.
Hmm.
Those architects tend to be far more open to something like a SIP construction, and they may very well have experience rather than having just heard about it. And I was going to bring up another point, and it went right out of my mind. So I'm sorry about that. But I remember. If you have an architect that is needing a guiding hand in working with SIPs, this is where the manufacturer being introduced to the architect at the beginning of the design, they can provide the architect with a lot of direction in terms of change the spacing of your glue lambs from 4 foot on center to 12 foot on center and let the SIPs do more work and spend less money on glue lambs, and let's save some money on the design. The manufacturers who have the experience within their project managers or their design team can help prevent an architect from making a costly mistake on the beginning of the design and lead them in the correct direction from the get-go. And I often do this is, I get a preliminary design or a rendering and say, this is what we want to build. And then I'll sit down with the architect and I'll say, well, on the walls, I would do this. And on the roof, I would change that. And these are the things that you can do that make the building more SIP friendly and therefore save money, not just in the cost of the panels, but also in the cost of the installation.
Great, great advice. So we're right almost at the top of the hour. We have time for one more question. And there go 2 hands up. Ted and Marianne, make it a quick question, please. And a quick answer.
I was just looking, I'm right now in the Midwest in Chicago, and probably the build that I'm going to do is going to be, first one will be in Florida. Are there, you gave us some companies on the West Coast. Are there some that are closer to this side?
I got them right in Florida. I got them in Florida, Carolina, Georgia. To go to SIPA, search out there and find out where the location of those manufacturers are, and you'll find plenty.
Okay, great. Thank you.
Yes, Ted.
Question is,
Hey, can I ask real quick, Al, because I missed in the beginning. This is Steve. Is this your brainchild, or how are you involved in it from the setup? And is it any of it prefabbed, or is it all custom?
I got involved in it because I was in the right place at the right time, and I stuck with it because I saw this common sense in it. Grew up swinging a hammer as a builder, split atoms and submarines for the Uncle Sam, and next thing I know, I'm running a foam plastic plant, and it went from there. So that's the very brief story, right? It's not my brainchild, not at all. I'm not, back in the 40s is when they were really kind of being invented. As far as panels being prefabricated, as a panelized system, it is a prefabricated panelized system. Does that mean you can go and buy a blank panel? You could. I don't recommend it, because as a blank panel, then you got to do all that fabrication work on site. Wrong answer. You want a panel that is ready to assemble, factory pre-assembled, something that's been designed, cut, and delivered so that you're ready to grab panel A1, marry it to A2, and start looking for the B wall. Work your way around. Is that it, or we got one more?
Can always ask one more.
Ted had a question, so quick question,
Okay, that's fine.
and then we're done.
it had to do with performance comparison.
What was the question, Ted?
We can't hear you, Ted.
Can't hear you. It's not coming through. Barely. Okay.
So
Marcy has one. Should we let her go?
Marcy, a quick question.
I heard you mention something about a mini split. What were you referring to?
In the world of air conditioning, we have a way to use mini splits are self-contained air conditioning and heating units that are wall mounted. You can't go anywhere in Africa or South America and walk into a building and find anything other than a mini split system. They're ductless. They're also referred to as ductless.
Also referred to as what?
Ductless, meaning there is no duct work.
Oh, okay.
And the vast majority of the buildings I design, that's what I use.
I heard
It heats or
HEAT pump.
It is a style of heat pump, yes.
Okay, fine. Thank you.
Oh,
Yep.
great. Well,
We
thank
did
you
it.
very much for being here. If people could stay on after and answer another question, but we need
Sure.
to go because we kept it to an hour. So thank you very much for being here. I hope you'll come back. We might have some more questions.
That sounds fine.
Thank you,
Peggy.
Al.
Good info.
Thank
Thanks,
you,
Al.
Al.